Example 3, a word problem. Two different taxi companies charge the following. Company A charges $3 plus 20 cents per kilometer. Company B charges $2.50 plus 25 cents per kilometer. We want to know at what distance the cost will be the same. For part A, we're going to model the equation or the problem with an equation. So we want to know basically when Company A is going to be equal to Company B, or when they're going to charge you both the same amount. The expression for Company A would be 0.20, that's 20 cents per kilometer. We're going to use the variable K to represent kilometers, plus $3 is your flat rate. And for Company B, it's going to be 25 cents per kilometer plus a flat rate of $2.50. For part B, then we're going to solve the problem. So we have 0.20k plus 3 equals 0.25k plus 250. Just like in the other examples we've done, we want to get the variables on one side and the numbers on the other. So I'm going to start off by doing the inverse of 0.25k, and the inverse of that is negative 0.25k. And I'm going to take that away from both sides. That's going to make a zero pair. I get negative 0.05k plus 3 equals 250. I'm going to take 3 away from each side to make that a zero pair. Negative 0.05k equals negative 0.5. Now all I have to do is divide both sides by negative 0.05. And I find out that k is going to be equal to 10. So for 10 kilometers, the cost is the same. So it doesn't matter which taxi company you go with. If you have to travel 10 kilometers, both of them are going to charge you the exact same amount. So part C says to verify the solution. I'm going to do that up here since I've run out of room. So our equation is 0.2k plus 3 equals 0.25k plus 250. And we're going to put 10 in for k. And then we work it out. 0.2 times 10 is 2. 0.25 times 10 is 2.5. And that should just be an equal sign there, folks. 2 plus 3 is 5. And 2.5 plus 2.5 is 5. So my left-hand side and my right-hand side are the same. So I know I've gotten the right answer.